Okay. But anyway, we will start now with the lecture. And I posted two files just a while ago. I posted a PowerPoint presentation and an Excel file. Okay, please download them if you haven't downloaded them yet. We'll be using that in our discussions this evening. Okay. Um, Let me open my presentation first, then we'll start with the lecture. Let me share my screen. So, so do you see my screen now?
Yes, sir.
Okay.
Yes, sir.
So for today, we'll be discussing the composition analysis. Yeah, by the way, I observed that no one is asking while I'm doing the lecture, but I'm sure you have questions. So don't be shy. Just call my attention if you have any questions, and then I'll stop. And then if you have any questions on the topics that I'm discussing at the very moment, then we'll discuss your question. Because I would want to ensure that everyone understands what we're discussing. I don't mind stopping, and I don't mind discussing further your questions. Okay. Yeah.
Sir, sir,
Yes.
sorry I'm late. I just want to ask some questions. Uh, when can we clarify our questions or queries regarding our past assignments?
Okay. On Friday, I'll be online from 4 to 5 p.m. So if you have any questions, okay, we'll be using the same link on Friday, 4 to 5 p.m. Okay, then if you have any questions on all the assignments, we'll discuss it there.
Thank you, sir.
Okay. Yeah. Okay. So we'll be discussing the composition analysis this evening. Okay. And what is the composition analysis of energy consumption? Because you can apply the composition analysis in a lot of fields, and one of the application is on energy consumption analysis. So you can imagine the composition analysis as a method that allows you to determine the contributions of different factors affecting a certain parameter. Like say, for example, energy consumption. So the energy consumption is strongly related, for example, with the GDP, right? With the economy. So normally, if you've got a good economy, if you have a high GDP, normally the energy consumption goes up. So we can consider that. You can consider the GDP as your activity. So as your GDP goes up, normally that would have an effect on your energy consumption. So that's what's called the activity effect. Another thing also is the activity mix would have an effect on the energy consumed, let's say in a country. So what do we mean by activity mix? So normally we're referring to the different sectors, let's say industrial sector, um, transport sector, let's say a farming sector, so residential, electricity production. So certain sectors would have a higher energy intensity requirements. So for example, uh, if the industry sector consumes more energy per GDP or per billion peso GDP, then an increase in the share of the industrial sector. Can we please make sure that all mics are in silent mode?
Sir,
Yeah.
sir, sorry. May I be excused for tonight because my father just fell from a ladder just now. I think.
Okay. Okay. No problem. No problem.
Okay.
Yeah.
Thank you, sir.
If you have any questions with the discussions, then we can discuss that also on Friday.
Thank you, sir. Thank you.
Okay. So yeah. So activity mix. So like for example, if let's say the the industry sector consumes more energy per unit of GDP. So an increase in the share of the energy of the energy increase in the share of the GDP of the industry sector leads to higher energy consumption. So the activity mix on how the GDP is distributed across the different sector also affects the total energy consumption. Okay. In addition, the sectoral energy mix also affects the energy consumption. So if the sectors in a country, for example, are very efficient, so it would have low energy mix, energy intensity. So yeah, that brings down your energy total energy consumption. So when you say decomposition analysis, let's say in this case for energy consumption, it's like quantifying what is the effect of GDP growth, quantifying what is the effect of the activity mix, quantifying what's the effect of energy intensity in the growth of energy total energy consumed. Okay, so if you look at okay, the figure on the right, okay, that's an example. Let's say you have the observed aggregate energy consumption. In 2005, it's 140 million tons of energy, um, um, tons of oil, energy, and then in 2010, it's 160 tons of oil. So the question then, you would know that there's a difference, right? The energy consumption increased by 20 million tons, okay, of oil. So the question now is how much is the effect of the overall activity? How much is the effect of the activity structure? How much is the effect of changes in energy intensity? Okay, on that difference on the change in energy consumed from 2005 to 2010. So if you conduct a composition analysis, you would come up would have something like the one presented on the screen. Like for example, it says that the overall activity or the increase in GDP, for example, is accountable actually for around 50 megatons of increase in a million tons of oil increased in energy consumption. While the activity structure changes in the activity structure has pushed down the energy consumed by negative 10 by 10 million tons of energy, tons of oil, and improvements in energy intensity. Normally, the energy intensity improves over time because there will be changes or developments on technology. So, so as you will see here, in fact, if there has been no changes, for example, in the activity structure and energy intensity, there has been no improvements in energy intensity, then in fact, the increase in energy consumption should have been higher. It should have been 50 million tons of oil. But because of changes in the other components and other factors, you end up with a total increase of only 20 billion tons of oil. So when you say decomposition analysis, you're simply accounting what is the effect or contribution of the different factors, okay, on the increase in energy. Okay. So what are the main motivations why you're doing decomposition analysis? So number one is to analyze the trend of energy consumption. So you would want to know whether you would have an idea whether it will increase in the future or go down in the future. So if you have a good idea on what are the contributing factors based on past data, and you're expecting, for example, that there will be an improvement in energy intensity, then you would see already how energy intensity affected energy consumption. Then you would have an idea. You would have an idea. Okay, what will be the trend or the trajectory of energy consumption in the future? Number two, estimate contributions of different factors to this trend. I think we've discussed that. And then identify driving factors to this trend, so you would know what are the key factors pushing or pushing up or pulling down the total energy consumed. And what do you do with that with those information? Then it can be fed to some policy development work and strategy development work. Okay. Like for example, if we're projecting that there will be a significant increase in GDP, okay, then we would, and based on past data, we would know already on based on past data, you know what are the contributions to activity mix and sectoral energy intensity, then you would know what will be your targets to manage the corresponding increase in energy use because of the projected increase in GDP. Okay. Any questions so far? Any problems are given
Hello.
away. Yes.
Sir, could you explain again what energy intensity means? I mean, how is it
Okay.
different from the activity?
Okay. So normally the overall activity is in terms of GDP, in terms of economics. Okay, so that's your GDP. Your activity mix is what is the distribution of your GDP. Let's say if you have a million peso GDP, um, we would say let's say that 50% of that comes from the industry, 20% from transport, let's say 30% from farming or agriculture. Okay, so that is your activity mix. Now, energy intensity refers to how much energy would you need to obtain a certain amount of GDP. So it will be in terms of so let's say we mentioned that you have a million peso GDP and 54% of that is traced from from industry. That means manufacturing, okay, and other industry work. So that means 500,000. And let's say based on data, the total energy consumed by the industry sector is 250,000 um, megawatt hour. So what is now, or let's say 105 of 250,000 megajoules. So what is now the energy intensity of the industrial sector? It's going to be what? What is the total GDP of the industrial sector? 500,000 peso. What is the total consumed? 250 megajoules. So the energy intensity now of the industrial sector is 500,000 divided by 250,000. So it means now it's the other way around. It's going to 250,000 megajoules divided by 500,000 million pesos. So that is zero point 0.5. So it means zero point 0.5 megajoules per peso GDP. So that is the energy intensity. That's the amount of energy that you would need to obtain a unit amount of your GDP. While the overall effect is more on the economy. It's more on the economy. Okay. So was I able to answer your question?
Yes, thank you.
Okay, but we'll discuss anyway with the examples. You will be able to discuss more about that later on. Okay, so um, okay, to start with the mathematical formulations, but you assume that V is an aggregate composed of n factors. And by the way,
Sir,
what?
you're not sharing your screen, sir.
Hello,
Sir,
are you
you're not
hearing me
sharing
now?
your screen.
I'm not sharing my screen. Okay. Um, let's see. Okay. Are you seeing my screen now?
Yes, sir, thanks.
Okay. So assume that V is an aggregate composed of n factors. Okay. V is the factor you're investigating. So in this case, it's energy. Okay. So V or energy in our case, okay, but it could take other parameters or other quantities, okay, or other products. So V, let's say the energy consumption of a country is simply equal to the energy consumption is simply equal to the energy consumption, the summation of the energy consumption of each of the energy consumption of each of the sector, right? So, for example, as mentioned earlier, let's say a country consists of four sectors. That would be agriculture, industrial, transport, and then you have industry, agriculture, industrial, transport, and then okay, let's leave it to three sectors. to simplify things. So let's say a country, the economy of the country consists of three sectors. You have industrial, agriculture, and transport. Okay. So the total energy consumption of the country is simply equal to the summation of the energy consumption of each of the sector, right? Okay. Now, how do we compute for the energy consumption of each sector? It's a function of the different factors affecting the energy consumption of a sector. Okay. So X becomes your factors. X will now be your factors. Okay. So when we revisit what we discussed earlier, okay, we're basically looking at, in terms of, if we're looking at energy consumption, we're looking at the overall activity, energy consumption of the sector, and activity. You have the overall activity level, which is the GDP. Okay, the activity share of sector I, and then the energy intensity of sector I. So if we can go back to the previous slide, remember you have the overall activity, activity mix, and then you have the sectoral intensity. Okay. So you can see that in the formula on the right. So the total energy consumed is equal to the summation of the energy consumed by each of the sector. And how do you compute now for the energy consumed by each of the sector? Is equal to the overall activity. Okay, could be the GDP of the country, multiplied by the activity share of the sector. So let's say 50% of the activity or of the GDP is raised from is provided by the industrial sector. So for the industrial sector, the S, or activity share of the industrial sector, is 0.5. K multiplied by the energy intensity of sector I. Let's say in this case for the industrial sector, let's say earlier we computed it to be around 0.5 megajoules per peso GDP. Okay, so that gives you the energy consumed, and to better visualize that, that is provided in the equation on the right. So you will see there Q, the activity share is what? Is equal to QI over Q. Okay, QI is the activity share of, or in this case, GDP share of the industrial sector divided by the total GDP. So if the GDP of the industrial sector, let's say, is 500,000, and the total GDP is 1 million, so what is now the activity share of sector I? It's going to be 0.5, right? Or 50%. And if you multiply that by the energy intensity, which is simply equal to the energy consumed by the sector divided by its divided by its GDP share. So if you look at that equation, it allows you to cancel the Q. It allows you to cancel the QI. So that is now also equal to the summation of the energy consumption of each of the sector. Okay. So, and if we set QI over Q as equals to SI, EI over QI is equals to II. So eventually you have E is equals to the summation of Q, which is the overall activity share multiplied by the activity share of sector I multiplied by the energy intensity of sector I. Okay. Any question with that? Is it clear how we derive energy? Okay, before we continue, because that's very important. Is it clear to everyone? E is equal to summation of Q times SI times II. Okay, we'll provide an example later on. Okay. Now, further assume that from period O to period T, the aggregate changes is equals to V O to VT. Okay. So O and T are time periods, so it could be 2020 and 2021. So your period O is 2020, your period T is 2021. Okay. So there's possible that there could be a change in energy consumed. Or in the example below there, their period O is 2005, your period T is 2010. The total consumed in period 5 in 2005 is 140. The total consumption in 2010 is 160. So there will be a difference, right? In that case, it's 20 million tons of oil. Okay. Million tons of oil equivalent. So you can assume V right now as the total consumption, as the amount of the energy consumed. Okay. So the idea behind it is the delta V is equal to the difference in this case, V is energy, is equal to the total difference in energy between period O and period T, which in an example, it's 20, right? Is that 20 will be equal to what? Will be equal to the changes provided by a number one, the overall activity level, a plus number two, changes provided by changes in activity share of sector I. So that is delta V x2. Okay. Okay, X is your factor. Plus you have the changes in provided by changes in energy intensity of sector I. So the idea is if you total the contributions of the change on the changes of the different factors, it should be equal to the total energy change between period O and period T. Okay, we've shown that earlier, right? So if your delta TE, for example, delta E total is 20 million tons equivalent, we can decompose that based on the values given, based on your data. For example, in this case, it could be 50, negative 10, and 20. And if you add everything, it should be equal to 20. Okay. Yeah. So the question now is, how do you solve for delta V? How do you solve for the contribution of each of the sector? Okay. You have the general formula for LMDI. It's an approach for decomposition analysis. Okay. It's logarithmic mean difference in division index, LMDI. And it says that okay, delta Vx, delta Vk, delta V xk. So what is delta V xk? Okay, it's equal to the contribution of factor xk. Okay. So it could be the contribution if your xk is your overall activity, so it's the contribution of overall activity. If your xk is your activity structure, then it's a contribution to the activity structure. If your delta Vxk is your energy intensity, then that is the contribution of the energy intensity. So it is equal to the summation of the logarithmic mean, okay, between the two time periods, okay, that you're investigating, multiplied by the logarithm of the ratio of, okay, the value of xk at time t and time and time o. Okay. So to prove that to prove this formula, okay, we can look at, okay, this discussions. So we said that the total changes in the energy is equal to the change contribution of the activity, change contribution of the structure or the shares across the different industry, plus the change in intensity. So if we apply this formula to each of those, they'll end up with the one with it. We'll end up with the equation on the second line, right? Okay. Now we can factor out, okay, the first first terms, right? Because it's common, and we can apply some logarithmic properties. You eventually end up with the form in the fourth line. Okay. Any question with this one? Okay, that is simply logarithmic properties, right? If you still remember. Okay. But what is QSI? If you recall, QSI is equal to energy, right? So ln Q at time t, Si at time t, and I at time t divided by Q at time O, S at time O, and I at time O is simply equal to the energy consumed of sector I at time t divided by energy consumed of sector O at time I, right? Okay. Now, so with that, okay, what is ln of ei raised to t o at time t and divided by ei at time o? We can also express that from logarithmic properties as ln et minus ln eio, right? So we can cancel out now the denominator and ln e and ln ei over eit over ln eio. And that is out now as the energy difference. So it only shows that this equation is actually equal to this, because delta E total is simply equal to the difference in energy at time t and time O. Now, why am I showing this? Because this is only applicable if this is satisfied. So, for first thing that you need to do if you want to do a decomposition analysis, you have to determine this equation, which in this case for energy composition, it won't change. It's always going to be this one. Okay. I have to stop sharing again. I think there's a problem every time I move my cursor when I'm on presentation mode, then my computer hangs. I mean, my PowerPoint hangs, so I have to share it again. Okay. So let's now proceed. Okay. I was not able to erase the slide. Okay, we'll skip that one. Okay, let's have an example. I think okay, this could be better understood with an example. Okay, let's say we have in here two sectors, sector one and sector two. You can assume that to be industry and farming, for example, or agriculture. And then the GDP of sector one at year zero, let's say it's 20 and 80. We can assume that to be million peso. Okay. So 20 million peso GDP from sector I, 80 million peso GDP from sector two. Okay. And say based on data, the energy consumed is 60 megajoules for sector I, for sector one, and 40 megajoules for sector two. Okay. So what is now the GDP share of sector I? So that is simply equal to what? The total GDP is 100. The contribution of sector I is 20. So the GDP share of sector I is equal to 20 over 100 or 0.2. We can do the same also for the GDP share of sector 2. So that is 80 over 100. Okay. Now, if you would observe the energy consumed by sector sector 1 is 60 megajoules, while the GDP is 20 million peso. So what is now the energy intensity? So how much energy would you need to provide a certain amount of a unit of GDP? So it's going to be what? It's going to be energy consumed is 60, the GDP is 20. So that will be 60 over 20 or 3. While for sector 2, that will be 40 over 80. Okay. So any questions so far? Are we clear?
Yeah.
Okay, so your GDP is your Q, your GDP share is your S, your energy intensity is your I. Okay. Of course, in year T, you're expecting a different set of values, so they can also compute accordingly GDP share and the energy intensity. Now, the main question here is, What is the contribution of the total GDP or activity, the GDP share or the activity shares, and the energy intensity in the change in energy consumed. So if you were to serve, it's from 147 to from 100, it went up to 147 megajoules. So where will we attribute that? So okay, kindly open your Excel sheets. I provide you with an Excel sheet. Okay, look first for example number 1. Okay, so okay, this is the same values that you have in the slides. So you have in your energy consumption. Okay, for sector 1, this is, by the way, your this is not your energy consumption, by the way. This is your, for a while. Yes, this is your energy consumption. So this is not supposed to be GDP. That's your energy consumption. That is your energy consumption. Okay. Your energy consumption is 60 and 40 for year 0 for sector 1 and 2. And it's 120 and 27 for sector for year 2, for year T. Okay. Any questions so far? It's there. GDP. Your GDP for sector 1 is 20 and 80. So you have there 20 and 80. Then for year T, it's 48 and 72. So we have there 48 and 72. Okay. So by the way, with this one, we have to, okay, this is simply equal to, it's better to sum this up. Anyway, it's just equated it to the, a sum, just do it this way. Oh. Okay, because I used the multiplier, sorry. Okay, so anyway, if you sum this, it's equal to 120, right? So in that case, I made use of the GDP share to compute for the 48 and 72. Okay, so I made use of this value and this value to compute to generate this. So that's why it's you have a circular referencing. Okay, so are we clear so far where we got these things? So you have there 20, 80, and 48 and 72. Now, what is the GDP share for sector 1 and sector 2? So you have in there 0.2. So 0.2, that's your GDP share, right? So that is 20 divided by 100. Okay, and then you have 0.8, okay, for sector 2. That is for year 0. And then for sector T, it's 0.4 and 0.6. Okay. So 0.4 and 0.6. So that is simply equal to 48 over 120. And then you have 72 over 120. And then you have also the energy intensity, right? So we plotted that earlier already. That is 3 and 0.5 for year 0 and 2.5 and 0.375 in year T. Okay. So we can compute now for the delta of the activity. If you remember the equation, so it's going to be your main quantity that you're breaking down is the energy. So the main quantity, the activity data is your GDP, your total GDP. So you're supposed also to use the energy consumed, the total energy consumed. So you have T12 minus C12, because if you, okay, let's try to relate that in our equation. Okay. Let me copy this so that you can easily, we can explain that in our equation. Or let me include the other one. Okay, let's put it here. Okay, so if you look at this equation, it's D12 minus C12. What is D12 minus C12? That's supposed to represent A minus B. Okay. If this is your energy consumed, okay, at time zero and time, at time t and time zero. So you have A minus B, so that is your energy consumed at time t minus energy consumed at time zero. Okay. Divided by ln of A minus ln of B. So this is the term that you have there. So D12 minus C12 divided by the difference of the ln's of D12 and C12, right? So any questions so far? Why are we using the total energy consumed? Because the GDP corresponds to the total energy consumed. Okay. Multiplied by ln of xk at time t and xk at time o. Okay. So in this case, we're quantifying the effect of the GDP. So you're going to use the GDP as your xk at time t and xk at time o. So that is 120 over 100, or D17 over C17. So we now have in there 22.2422773. Okay. What is now the contribution of changes in the economic share of the sectors? Okay. The economic share, so that is your GDP share, right? So if you look at this equation, we have two sectors, because it says there summation of each of the sector. For the first one, you don't have to sum it up anymore because you're referring to the total GDP. Okay, this time, you have two sets of economic shares. That's the economic share of sector 1 and economic share of sector 2. Okay. So this time, if you would observe, for the first term, we made use of the energy consumed values at time t and time zero for sector 1 because we're computing for the contribution of sector 1, changes in sector 1, which is from 0.2 it went up to 0.4. Okay, so that is T23 over C23. K plus, because it says it's a summation, plus the share of the change in the GDP share of sector 2. So this time you have D24 over C24, but you make use now of the energy changes in sector 2. So are we clear so far? Okay. And then, okay, lastly, is for the energy intensity. You have a different energy intensity for sector 1 and different energy intensity for sector 2. So we have to account now for the contribution of each of the changes in the energy intensity of each of the sectors. So okay, this time again, since we're accounting it by sector, so we have to match it with the energy consumed by sector. So earlier, for the activity share, we're referring to the change in the whole economy. So then we have to, that's why we made use of the energy change, total energy change, regardless of the sector. It's actually the summation of the energy changes on each of the sector. So this is now what we have. This is actually what we're looking for. So we can say that the changes in the change in 22.24 megajoules, assuming it were energy in terms of megajoules, 22.24 megajoules of the change is traced to an increase in GDP. 50.484 megajoules is traced to changes in the GDP shares by sector. While improvements in energy intensity by sector accounted for a reduction of 25.297 megajoules. So you have there 47.429. Okay, now normally a difference of plus and minus 5 to 6% is acceptable, or it's valid. So in this case, if you compute for that, that's actually a very small difference relative to 47. Because note that the difference of your energy consumed is 147 minus 100. It's equal to 47. So your total value is within plus and minus 5 to 6% of your actual change difference in energy. Okay. Now, if you got a different value here, then it means that your result, if you've got a very high error, that means your results are unreliable. So you might need to make use of some other decomposition approaches. Okay. So any questions so far?
So,
Yes.
when the GDP increase and the intensity decrease, it means that actually there is more efficiency in
Yes. Your
the use of the energy.
yes, the improvements in the efficiency actually brought down the energy consumed by 25.29 megajoules. However, the overall from year zero to year T, we still got an increase of 47, around 47 megajoules, because the effect of the increase in the GDP combined with the increase with the effect of the changes in the economic share overshadowed whatever improvements in energy efficiency that we were able to implement. Yeah. So it allows you to analyze where are your where can you trace the changes? Okay. So you can imagine this actually as could be in a time series, right? So it could be in the example actually in your assignment, I will be asking you to work on this data set. It's the data of Iran from 2003 to 2014. So if you do that in the time series, it allows you now to understand what were the contributions of the different factors over time in the evolution of the energy consumption of the country. And then you will see now trends. Okay. But for the meantime, we're just looking at the one time step. So any questions so far? Okay. So let's proceed. This approach is also commonly applied, okay, in the composition of energy-related emissions, let's say greenhouse gases. Okay. So normally for greenhouse gases, you're dealing with five-factor case. But later on, for your assignment, I'll ask you to work on a 6-factor case. Okay. So again, very first step is to set up your equation. Okay, is to set up your equation. You need to determine what factors you're going to account or to look at. So in here, your overall activity is Q. That's also still your GDP. And that GDP could be distributed to the different sectors. So that is your SI or QI over Q, right? Similar to what we had earlier. Now, and you know also that the energy consumption intensity for each sector could vary. Okay. So your energy consumption, that's your intensity effect, is equal to, if you recall, that's equal to energy consumed by the sector divided by the GDP share of the sector, or the GDP of the contribution of the sector, which is QI. Okay. So if you recall, that is your I, right? Earlier. Yeah, but this time there are new terms, because if you know the total amount consumed by the sector, that energy consumed could be coming from different fuels. Okay, so that is now what we refer to the sectoral energy mix. So if a sector, let's say, consumes 100 megajoules, how much percentage of that is traced to the burning of oil? How much percentage of that is derived from solar energy or from coal? So that is your energy mix. So that's why if they're EIJ, J this time refers to the type of fuel your I is your sector. So EIJ is the total energy consumed of a sector I of total um, fuel J consumed of sector I divided by the total energy consumed of sector I. So it could be zero point 0.5, 0.5 means zero point 0.5 the total energy consumed is, let's say for oil, is raised to oil. Okay. And then you have the emission factors. So for a given amount of oil burned, you have corresponding amount of greenhouse gases released. That's why it's important to break down the energy consumed in terms of the energy mix because you have different emission factors for different fuels. Okay, that's the difference between the composition need to analyze energy-related emissions compared to just the composition analysis of energy consumption. Because for energy consumption, you don't have to break it down in terms of the energy mix. Okay. While for the energy-related emissions, the compositions, you have to break it down to in terms of energy mix because you have different emission factors for the different forms of energy. Okay. So if you look at this, okay, we can cancel out your Q, we can cancel out your QI, we can cancel out your EI, we can cancel out your EIJ. Okay, that leaves us now with summation of CIJ. So we can say that these two are equal. So what factors now are going to investigate? Of course, you have your Q. You have QI over Q, that is your sectoral GDP share. EI over QI, if you recall, that is your intensity. Now have your MIJ, which is your energy mix. Okay, so the percentage of a certain type of fuel, okay, for a given sector, so that is your MIJ. Your CIJ is the amount of emissions per amount of fuel burned of a particular fuel. That is your emission factor. Okay, let's represent that as your U. Okay. So UIJ is your emission factor of fuel J in sector I. So applying what we've discussed earlier, okay, your C, by the way, is your amount of emissions. Applying what we've discussed earlier, okay, the total difference in emissions from year T, from year 0 to year T is simply equal to the contributions, the summation of the contributions of each of the factor, which in this case is Q, S, I, M, and U. Okay. So any questions so far? So again, the very first step is to set up your mother equation. So your mother equation is the parameter you're decomposing as a function of the different factors that you're investigating. Okay. In this case is Q, S, I, M, and U. Okay. And it should come in this form. Okay. Because recall that you need to satisfy this condition. And to satisfy that condition, then everything should be expressed in terms of ratio such that you cancel terms out, you'll end up in this case with summation of CIJ. Okay. And normally, again, for energy-related emissions, it comes in this form. But this doesn't mean that you're limited to this form. You can further break this down if you want. So for example, we have, we can, for example, introduce in here emission controls. So if you put in emission controls, then you have to break down now the energy mix into, let's say, coal with a coal sequestration system and a coal without the coal sequestration with a greenhouse gas sequestration system. So because the energy intensity or the energy factor in those cases would be different. But you just have to add another term in here. In the example, in your assignment, your main activity factor will be population. Because population, normally energy, GDP changes with population. The higher the population, the higher is your GDP. So, there will be another term added in here. Okay. I'll discuss that later on. Okay. Let's have an example. Let's say again, you have two sectors. You have a two-sector economy, and then eh, both sectors utilizes coal and oil. So again, we have to break it down, or we have to break our data in terms of the energy mixes. See if you recall that is your emissions, right? So let's say for sector one, the amount of emissions, say greenhouse gases released is 63 tons, just for example. We use tons. Oil is 46.5 tons. Okay. And for sector two, it's 42 and 31. Okay, U, if you recall, what is your U? U is your emission factor. So let's say in here, it's 4.2 kilogram per ton of coal, 4.2 kilogram per megajoules, let's say, of coal burn, or 3.1 tons per megajoule of oil burn. So these are your emission factors. Okay, it's possible that you can have similar emission factors. It's possible also that it could differ. Normally for greenhouse gases, it's the same because it's based on the amount of carbon in your fuel. But if you're dealing with pollutants, it could be different. Okay, because it all depends on the technology used for the burning. For example, you're burning diesel in a Euro 4 engine would release lower PM emissions, let's say if your gases or emissions is PM, particulate matter, compared to burning diesel, same amount of fuel or same amount of diesel in a pre-Euro engine. So this could vary, but for greenhouse gases, normally it's the same because normally it's based on the amount of carbon in the fuel. Okay. Your E is the energy consumed. So in this case, you can assume this to be megajoules. So 15 megajoules of coal is used by sector one, 15 megajoules of oil is used by sector one, so on and so forth. Your Q, these are the GDP share of sector one and GDP share of sector two. So your total energy or GDP for all industry is 50. Okay, and then for all industries is 50. Then this is now your GDP share, right? So 0.2 came from where? 10 over 50. So that is 0.2. The share in the economy of sector 2 is 40 over 50. That is 0.8. Okay, energy intensity, we had this before, right? So that is computed by what? Okay, we add this to is your total consume of sector 1. So that is 30 divided by 10, which is the GDP share. GDP contribution of sector 1. So you have 30 over 10, you have there 3.0. You have 20 over 40, you have there 0.5. Okay. Here T is also the same. You can interpret it as in the same way. Okay. But of course, if you look at here, you have an increase in Q from 50 to 80. So somehow that would have some positive contributions to your energy consumption. That would increase your energy consumption. Your energy intensity. Normally, you don't add up your energy intensities. Okay. Normally, you would do weighted averages. Okay, with the share. Okay. So in this case, that will be 0.5 of 2 plus 0.5 of 0.4. 0.5 times 0.4. That is 1.2. Okay. So we would assume already that you're expecting an improvement in the energy consumption. It would have a reduction effect because you're able to increase. It would have an increasing effect because your energy intensity increased. Okay. Okay. Then your emissions, you will see here that it increased. So because number one, we expected an increase from the increase in GDP. We're expecting increase from the increase in intensity. Okay. And there was also an increase in the energy consumption. But we would want to know what are the contribution of each. That's why we have to do now the composition analysis. Okay, to demonstrate how it's done, please open your Excel sheets again. Yeah, I'll share again my screen. Not this one. Okay. Is opening Excel sheets. Let's go now to example number 2. Okay. So we can rewrite the values in the table in this way. So let's say year 0 is year 1 and then T is year 2. Emissions by sector. So we just got this from the slide earlier. Sector 1, 109.5. Sector 2 is 73 in year 1, and then 109.5 increased to 258. While for sector 2, the amount of emissions decreased from 73 to 53.4 in year 2. Okay, sectoral emissions, we can break it down in terms of coal and oil. So we can derive it from the table that I gave earlier, right? So it's this one. We can derive it from here, okay? So we're referring to amount of emissions. Recall that for sector 1, coal emissions, so sector 1 coal emissions. Sector 1 coal emissions is 63, so that's why we have 63 in here. So we can just have to match the values in the table. So for sector 1, year 1, the emissions of 119.5 is broken down into 60, is raised to 63 from coal and then 46.5 from oil. Okay. You can do the same for year 2. And for sector 2 emissions, similar approach. You can get 42 and 31 for coal and oil for year 1, and then you have 23.4 and 30 for year 2. Okay, GDP shares, same, we just got this from the table. For sector 1, year 1 is 10. Sector 2, year 1 is 40. That adds up to 50. Okay, so you simply have to add the sectoral GDPs. You do the same also for year 2. GDP share. So if you would recall, okay, that is just a percentage of the GDP that is traced to sector 2, sector 1 in this case. So 10 over 50, so you have in there 0.2, and then you have 40 over 50, that is 0.8. You do the same also for year 2. So any questions so far? So we now have the values set already for Q. We already was able to set the values for S that we're going to use in the equations later on. And then we now try to look at energy intensity. So I guess we discussed this earlier, right? So this came from where? This came from energy consumed in year 1. If you recall, for year 1 energy consumed, we can get it from the table. It's sector 1, year 1. It's energy consumed. It's for sector 1 is 15 plus 15, that is 30 divided by 10 for GDP. So you have 3.0. So we just have to copy it here. Okay. So you now get your energy intensity values. In your energy mix, you just have to determine how much of your energy consumed by sector 1 is derived from coal and derived from oil. So again, that is simply equal to 15 over 30. As you recall, coal is 15 on this table. 15, total is 30. So 15 over 30. Okay. So 50% of your energy used by sector 1 in year 0, in year 1 is based to coal, and 50% of that also is oil. But for year 2, the amount consumed, contribution of coal is lower compared to year 1. So it went down to 0.25, while that of oil increased to 0.75. You can do the same also for sector 2 and for sector 2 for year 1 and year 0. Okay. So we have pretty much set up also already your energy mix or your M. We're now going to set up the emission factors. Okay, it's given in the table. You have your emission factors. Okay, so we now just have to run it, run out the equations. Okay, this time we're investigating. We're breaking down the emissions. So our reference quantity now is emissions. Earlier, if you recall, a reference quantity is energy because we're trying to decompose energy, the increase in energy or changes in energy. This time it's emissions. Okay. So this is if you we're looking at the contribution of the activity values. Your activity value in here is Q or GDP. That is total. We're not breaking it down. So we refer that also to the we relate that to the total emissions. Okay. By the way, when do you know that you need to break it down or not? So you can go back to your equation. Okay. Your Q, okay, you don't have to break it down because there's no subscript here that refers to the total. To refer it to the total emissions. Okay. Your SI, which is your share, you have a subscript I. I refers to the sector. So it means you have to break down your share by sector. Okay. Your intensity is also when it comes to the subscript I, so you have to break it down in terms of by sector. Okay. Your energy mix is MIJ, so you have to break it down in terms of by sector and by energy type. Okay. So if you look at in here, in our equation, when we compute for the energy mix, you have to break it down by sector. So you have it consists of the let's go first to the economic share. Sorry. So for the activity, you don't have to break it down, but for the delta eco share, you broke it down into the two sectors, then add them. Okay, so you simply add them because this is SI, right? I refers to the sector, so you add up all the mix of the sector. So since it's by sector, so we have to relate it to the emissions by sector. Okay. Okay. I is also by sector, if you recall, so you have to break it down to sector 1 and sector 2. Again, it's by sector, so you have to relate it to the emissions by sector. Okay. Now recall that the mix is MIJ. I refers to the sector, J refers to the type of fuel. So you have to break it down to by sector and by fuel. So in that case, it is our energy mix, right? Okay, for coal, you have to relate it to the amount of emissions produced by coal in sector 1. Also referring to the change in amount of coal consumption, coal mix, okay, in sector 1. So you have in here 4 terms, and you have to add them all. Okay. Delta emission factor is the same, 4 terms. If you recall, that is UIJ, right? So you need to have 4 terms there. Okay, so you just have to add them all. So you have a summary of results. Okay. For delta ACT, it's 113.3825. Delta C eco share is 129.3027. Delta of the intensity is negative 84.2446. Delta mix is given there, and then delta emission factor. Okay. So what does this mean? So it means then that the changes in the activity factor actually have an increasing effect on the total energy, total greenhouse gas emissions released between year 1 and year 2. Increases in year 1 between year 1 and year 2. The changes in eco-share also had an increasing effect on the greenhouse gas emission from year 1 and year 2. improvements. Okay, although we've seen earlier that there was some increase in intensity, but when combined with changes in the other factors like the share, um, it actually resulted to in a reduction, or it contributed the changes in energy intensity actually led to a decrease in emissions by about 84.244 tons of greenhouse gases. For M, changes in M also led to increases in decreases in the emissions, and changes in the emission factor, okay, also led to increases or decreases in the emission factor. So if you total everything, okay, it's 135.6128. Okay, we can check what's the difference in emissions total. 128.9. So that's actually within 6% if you compute for it. Okay, so that should be that should be acceptable, right? Okay, yeah. So that's how you do a decomposition analysis. Okay, this is a very powerful tool. It's a very simple tool, and yet you can do a lot of things with it. If you search in the internet, you can see a lot of papers related to decomposition analysis. Yeah, and then we did actually a couple of papers on it. Um, I'll okay, try to see some. Okay, let's see. Okay, that is one, and then we've got another one. Have I not shared this one yet?
No.
Okay, I'll look for the other one. You've got because that the other one that's where actually your assignment was based. Okay, I'll stop sharing this first, and I'll look for it, and then I'm going to present it to the class. Okay, there it is. Okay, I'm going to share again my screen. Okay, these are two papers that we did before. Okay, this one is the CO2 emissions of Iran. So we had a co-author, an Iranian co-author based in Germany. Yeah. So this is actually where your assignment was based.
Sir, that's already posted.
This was posted already.
Yes.
Okay. So your assignment is based on this, so you can check actually your results based on this one. Okay. This is exactly your assignment. So and this one is Iran, and then we did something also for the Philippines, but we're looking at transportation energy consumption. Um, the two are quite different in the sense that for the Philippine study, they made use of a lot of proxy indicators because of lack of local data. So it's really quite hard to do some studies here in the Philippines due to lack of data. But when you go through this, you will see how we did it. Sometimes you have to do that. You need to have some proxy data because you have no other choice. Okay, so I guess right now you would understand already what these things means, right? So these are now the factors that we're investigating. So I think this equation looks familiar to you. We discussed this earlier. So yeah. So and then finally these are the results. So this is how it looks like. Okay, when when you put that in a time series. So you will see what were the who contributed, what caused the increases and what causes the decreases, okay, over time. Okay, if you do that in a time series. Okay, this one, as I've said, is for for Iran. So you'll see in there also how it changed. Okay. So this is exactly the same. This is exactly the same project or assignment that I'm giving you. I'm also giving you the values that we use in this study. So you should be able to check it out. Check your results. Okay. You're given here the Iran emissions. Okay. Just let me discuss this this assignment. So you have the population, and then you have in here the total GDP. Okay. The total GDP is a summation of the GDP contribution of each of the sectors. So this time, you're dealing with how many sectors? You have industry, transport, storage and communications, commercial and other services, agriculture, fishing, and then you have electricity, water, natural gases, and natural gas. Okay, so these are the energy sectors. So you have the breakdown. So from there, it allows you to get the, if you recall, the economic share or structure, right? We did this earlier. Okay. And then you also have now the energy consumption. So that's the energy consumption for energy consumption for transport. So by sector. So given the energy consumption by sector, broken down in terms of type of fuel. Okay, so it sounds familiar, right? We did that earlier, but we only dealt with two fuels, coal and oil. This time you have a bigger set of fuel. Okay. Okay, and then yeah, so you have there the different energy. Okay, you have also fishing, but when fishing is negligible. Okay, then of course you have losses also, so you have to account for that. Okay, then you have emissions. Okay, emission contributions. You can you also trace it from this uh, the derivation of these values. You can refer that to this to the sheet. Okay, amount of emissions. Okay, yeah. So from there you can get the emission factors, right? So if you know, recall emission factor is equal to what? Is equal to the total amount of emissions per amount of energy consumed. So you have the energy consumed, you have the total emissions, so you can easily get the emission factor from there. Okay, yeah. So I would want you now, so for assignment, I would want you to do a decomposition analysis from 2003 to 2014. It's going to be 2013 only because normally it comes in pair, right? 2003 to 2004, 2004 to 2005. So you have 2003 to 2014. Okay. So I want you to do a decomposition analysis of the greenhouse gases of Iran. But yeah, I want you to take into account population. Earlier, all our activity data are based on what? Based on GDP, right? At this time, I want you to add population. We'll see how are you going to do that. If you can refer to the paper that I posted earlier. Okay, it should give you some inputs on how to do it. Okay. The next question now is, okay, for this one, I think it's quite easy because you've got already the values, right? The question is, where do you get these values? Okay. Population, you normally can get that from census. Okay, if you do that in the Philippines, you can. So definitely that is okay. We have values for that. We have data for the population. Okay, where do you get the data for GDP? There's a lot of sources. You can check the input-output table of DTI or maybe there are GDP reports or economic reports of the country. It's freely available. Okay, so you can easily get this one. Now the question is, where do you get industry energy consumption data. Okay, DOE would have some. Okay, but I guess locally the main challenge is whether the sector classifications are the same, because this would only work if you have similar sector classifications. Okay, right? Or you can also check. Let me see. Let me check this one first. Okay, let's check this one. Because you can also do Sankey, you can also look at the Sankey diagram provided by IEA. It's just loading slow. Let's check, let's say, for Philippines. Okay, yeah. Okay, I'll share now my screen. Okay. Yeah, you can get, for each of the country, you can actually get this one from IEA. The good thing with this is it's in time series, so you can get the value. You can actually see how it changed over time. So you have there the breakdown for the different sectors. So you would know what's the energy consumption for each of the sector. Yeah, and then you would also get in here what's the distribution in terms of fuel, So that is for transport. And this is for energy, for the industry. Okay, that's for the others. Okay. And then you have in here non-energy use. So if you have a way to reclassify, GDP in terms of industry, transport, others, and non-energy, then definitely can do something similar also for the Philippines. Okay. Let's try to look at Iran. Okay, so it's also structured that way. So yeah, so it looks like that's how it's done. So we just if you want to apply the data from the IEA, then you have to find a way to reclassify GDP data in terms of industry, transport, others, and then you have non-energy. Okay, and normally with this one you can get definitions of each of these sectors so that you can properly classify them. Okay. But the thing with this is you, you have to paint. You have to, like, in detail. You have to get the data for each of the country. That would take some time. For each year, that takes some time. Okay, but this is a very good source of data. So what else do we have here? So we get this from government records. Okay, this one you can get that from IEA data, the Sankey diagram, or you can check also with the Department of Energy. Normally, they might have those. CO2 emissions, you can compute for those. Okay, that would be quite easy because you just have to determine the carbon content. Or in fact, if you look at the GREET model that I gave you earlier, it provides or contains the carbon content of each of the fuel, and you just have to multiply that by what? Okay, C. Carbon is molecular weight of carbon is 12. So for each, if you assume that CO is 0, so for each C in your fuel content, Okay, that is 12. That is 12 molecular weight, 12 grams, right? If that bonds with the O2, which has a molecular weight of 32, so the molecular weight of CO2 is 12 plus that 12 plus 32. That's what, 48? Yes, right? 12 plus 42, yeah, it's 48.
No,
So
40,
44 or 48? 44?
44.
44. So 44 over 12 is what? 44 over 12 is, we can check. 44 over 12, 3.66. So you simply have to get the total amount of carbon in the fuel multiplied by that by 3.66. If that should somehow give you the amount of CO2 released. Okay. But it would be good, however, to that, although that would be quite a crude way because you have to factor in also the CH4 form. But you can get also emission factors for the CH4 and the N2O. You can get also emission factors for N2O by fuel type. And I think I showed you that earlier, right? With the grid. So you can factor in those things. And in here, when you're looking at CO2, this one refers to CO2 equivalent. If you recall from our discussions on LCA, you have to multiply the amount of a certain gas by its greenhouse gas potential, right? And that is now your CO2 equivalent. So for example, so for CH4, it's 21. So whatever is your CH4 emissions, you multiply that by 21. For carbon monoxide, it's 2. You've got quite a high multiplier for N2O. So I think I gave you that value earlier. So okay, so you can compute for the CO2 emissions okay, on a separate spreadsheet, then just copy everything okay, on your main spreadsheet and then do the decomposition analysis. Okay. So this will be your assignment. Okay. So next meeting, we won't be having any lecture. Instead, we'll just be having reporting in class. We have 3 assignments to look at. Okay, number 1 on LCA, number 2 on the mobile emissions modeling, and then number 3, okay, assignment on decomposition analysis. Okay. Any questions?
Hello, sir.
Yeah.
Will everyone be presenting on Tuesday, or will you just select some students to share their work?
I'll just select some students. So it means I'll be calling 3 of you.
Okay, sir.
Okay, meeting. Okay, all of you will get the chance to present your work. We just don't know when. Okay. So I'll be calling you at random, and those that I've called, then you're already safe for the next assignment. Okay. So it always pays to be ahead, so that peace you'll have peace of mind already for our next assignments. Okay. Any other questions? Okay. So if none, that will be all for today. But since I'm also meeting you on Friday, right? From 4 to 5, if you have any questions on the assignments. So I would want you first to look at the assignments, the 3 assignments, then check if you have any questions. It will be good if you prepare already the list of questions. So that will greatly facilitate our discussions on Friday. Okay. Any questions? By the way, have I shared already the paper on the Philippine transport decomposition, or just the Iran thing?
Just the Iran.
Okay, I'll also post online the paper on the Philippines transport. So that should give you additional references. Okay. So if there are no other questions, that will be all for tonight. Okay, I'll meet you on Friday from 4 o'clock to 5 p.m.
So, sir, I have a question.
Okay, sure. Yeah.
So I don't know, when can we submit the assignments, or we don't need to submit the assignment?
You don't need to submit the assignments. You'll be
To present.
when you are called. When you are called.
Okay.
I'll be calling one student for each of the assignment, and that will now be your grade for the assignments for the whole term. Yeah. So that will be on random. So if you were called already, it means you won't be called anymore next time.
Okay. Thank you, sir.
Yeah. So I guess for now you've discussed already three modeling work, and you might be able to think already of things that you can do for your term paper. So you can look at the possibility of doing an LCA. You can consider doing an emissions modeling work, or you can also consider doing some decomposition analysis.
Sir, is this the group work, the term paper?
Yes,
Or
the term paper. It's I think I announced it last time, right? It's a group work, per group. I'll check again. I'll check again.
thank you, sir.
From what I remember, it's a two per group. Check. Mhm. Yeah. Okay. Let me check. It's a group term project. Yeah, three students per group. Okay. Yeah. So you need already to as early as now. It would be good if you can look for your group. If you form your groups already, so you can start working on them on the project. Yeah. Okay. Any other questions? Yeah, if none, then that would be all for tonight, and then see you again on Friday. But on Friday, it's not compulsory. You can attend the class if the discussions. If you have questions, if you don't have any questions, you don't have to be there. Okay. Yeah. Okay. So I think that will be all for tonight, and then see you on Friday. Okay. Thank you.
Okay, thank you, Prof. Yeah,
Thank you, sir.
and have a good day, everyone.
Thank you, sir.
Okay. Thank you. Bye.